From the previous two videos, we have been discussing about the Iris dataset, and we have actually discussed that what is the significance of a machine learning algorithm, how can we predict the data based upon the machine learning algorithm, that is the k-means clustering algorithm. Okay. In this video, primarily, we are going to talk about the accuracy of the model. Okay. So, this is the machine learning model that we have created and we need to find its accuracy. So for finding out the accuracy, what is the thing that you need to keep in mind? The thing is that what the machine learning algorithm has predicted. If you take a look at this particular parameter, that is clusters k-means, if you see this as a weird kind of an icon, it is because it is not a generated icon. It's not actually text, it's not actually a number, but it is a generated icon, an icon or a parameter that has been created by the machine learning algorithm. Okay, that means this is the data that the algorithm has predicted. Always look for what parameter the algorithm has predicted, right? Now over here, what is happening is that the k-means clustering algorithm is a supervised machine learning algorithm. Now what is a supervised machine learning algorithm? It is an algorithm in which we already have the data and we try to compare our model with that already present data. Okay, in this case our data is in this species parameter because we already knew that there were 3 species of flowers and how they were looking. So we got it in this actual data, that is the species parameter. And the same thing we tried to generate with the help of the algorithm. So we generated this clusters k-means parameter. That means if we want to find out the accuracy of the model, we have to compare these two things, that is the actual parameter and the generated or the derived parameter, right? If you are still finding difficulty in understanding this, you can simply understand this as, this is the sheet which we used. So in the colors part, species is used, right? Similarly, in this ML algorithm, in the colors part, this clusters is used. That means these two will be compared to find out the accuracy. If the model has generated all the correct answers, then it would be 100% accurate model. Otherwise, the accuracy would differ. Okay. So what we are going to do to generate the accuracy is we are going to create a new sheet, rename it as accuracy. Okay. Here we are going to create a new calculated field and name it as accuracy again. Now in this, what we are going to do is compare these two. So how are we going to compare? Let's just get the first parameter, that is clusters k-means, and compare it with the second parameter, that is the species parameter. So if they both are equal, then it would generate a true value, otherwise it would generate a false value. That's the simple code that I've written. If you want, you can just throw in the if statement, the logical statement, and get all that correct, incorrect, or accurate, not accurate, any kind of the parameters. But I'm fine with true, false, because what we are concerned with is just the accuracy, nothing else, right? Click on apply, click on OK. Now the accuracy has been generated. It has got a bunch of true false data. That means if the values are same, it would generate true, otherwise it would generate false. Let's just get the accuracy over here. So you see it has two values, false and true. Now if you just generate the count of the iris into the text part, it would tell you that how many true values are there and how many false values are there. If you remember, when we discussed about the Iris dataset, we told you that there were a total of 150 records. So out of the 150 records, 144 has been classified correctly by our machine learning algorithms and 6 have been identified as incorrectly. So that is a pretty good accuracy score that we are getting, right? That is the number of the records actually that we are getting correct. If you want to find out the accuracy score, how can you find it? You can just go to this icon, go to quick table calculation, percent of total. So true is 96%. That means this is the accuracy of the model. Our model is 96% accurate. Furthermore, what you can do is bring the accuracy into the filters and make sure only the true values are visible. Click on apply, click on OK. you can just uncheck its header. So the accuracy is a 100%. Sorry. For this, you have to generate a calculated field instead of the percent of total over here, because that would give you 100% accuracy in the case of the true false values, right? So actually 96% is a pretty good accuracy for a model. Now this model is created. You can use this model to predict any new data. Now if you want, you can create a dashboard out of it. That's for the here. That's the actual data on the basis of the petal. Okay, this is the ML algorithm, or this is what our ML algorithm has generated. We can just remove one of these because we are happy with it. Furthermore, I'm just going to change it to floating, so I can bring it here. Right, and I can also get this accuracy score as a floating part into here. Yep, that's fine. I think that's good. Okay, or a little bit more. Yeah. Now if you just go into the presentation mode, this is what we are getting. This is the actual data, this is the algorithm, this is the accuracy, and these are the species. So that's the whole dashboard that we have created out of the machine learning algorithm, and that's all that you need to do in data science, in generating the visualizations and finding out their accuracy of the model, etc. Now the thing that must come to your mind is that one question that we discussed earlier was the importance of naming them correctly, right? Suppose I go to this ML algo, we have clusters, k-means. Let's just remove that. Go to edit group, and here instead of Iris setosa, if I just name it as just setosa. Okay, so setosa is a species name, right? I have named it as setosa, and let's just keep these two as it is. Click on apply, click on OK. Now what happens is, if we go to the accuracy part, you see the accuracy has changed. Now my model is giving a 62.67% accuracy. Why? If you take a look at this calculated field, go to edit it. So it is directly comparing the species name with what we had in this k-means clusters, right? And if there is a slight difference in the spelling, or if there is even a slight difference in the casing, or if there is a slight difference in adding the symbols, then it would change the results. It would classify it as false, right? So you need to make sure that you are not doing any kind of these mistakes, and you're getting the correct data for all this data in order to get the correct accuracy for your model, because this is not the standard way of getting the accuracy of the model. This is something that we have created, right? So that's it. Now this is a heat map that I have generated, the data basically that I have generated. What I have done is, on the basis of petal length and petal width, I have tried to classify it on the basis of the clusters. This is the cluster data. It is classified into cluster 1, it is into cluster 2, and it is in cluster 3. But the color part I have taken as species. So you can see that some of this is of Iris virginica, but it has been classified as orange color, that is versicolor, in our algorithm. And similarly, this is the erroneous data. So like this, you can find out that which data is erroneous and which is correctly identified by the machine learning algorithm. So that's all for this video, and that's all for this analysis. Thanks for watching.